I don't know what happened. I think my Zoom just upgraded and I was sent out of this class. So, but I've not yet continued. So we were to make sin theta over 2 the subject. And in that case, we shall have sin squared theta over 2 is equals to cos is equals to 1 minus cos theta, and all this over 2, because I simply just I can take this one on this other side, then bring this one on this side, and then I divide by 2. So I'll get that. So this implies that sine theta over 2 is equals to plus or minus the square root of 1 minus cos theta over 2. So this one is the half angle formula for sine. Half angle formula sine. So similarly, you can also show the half angle formula for cos. Also, cos, we have the half angle formula for cos. Half angle formula for cos. So we still go back and use the same. We have said cos theta is equals to what? Is equals to cos squared theta over 2, then minus sine squared theta over 2. This is from the previous proof of sine theta over 2, whereby we decided to pick from the compound angle formula or double angle formula, we decided to have the half angle or maybe the singular. I divided through by 2. So you're going to have, in this case, from, if you can check this formula here, cos squared theta over 2 plus sine squared theta over 2 is equals to 1. So you can have cos, you can have sine squared theta over 2. You have sine. So from sine squared theta over 2 plus cos squared theta over 2 is equals to 1. We have sine squared theta over 2 being equal to 1 minus cos squared theta over 2. And so that one means we're going to have cos theta is equals to 1 is equals to cos squared theta over 2 is equals to cos squared theta over 2, and then minus into 1 minus cos squared theta over 2. So if you open up this bracket, we're going to have cos theta is equals to 2 cos squared theta over 2 minus 1. Again, making cos squared theta over 2 subject. Instead, in fact, let us just make cos theta over 2 subject, so that we're going to have, you're going to bring this negative 1 on the other end, on the other side of the equal sign, have 2 cos squared theta over 2 being equal to 1 plus cos theta. So, and if that's the case, then we shall have cos squared theta over 2 is equals to 1 plus cos theta, all this divided by 2, implying that cos theta over 2 is equals to the square root plus or minus of 1 plus cos theta over 2. So you can see this one here, it's the half angle formula. Half angle formula for cosine. So it becomes easier for us now to obtain the half angle formula for tan, because you simply remember that it is simple for us to remember that tan theta is equal to sin theta over cos theta. So half angle formula for tangent. So for tangent, we say that clearly tan theta is equal to sin theta over cos theta. And so therefore, you can expand this one. Therefore, tan theta over 2 is equal to sin theta over 2 divided by cos theta over 2. So therefore, here you're going to have tan theta over 2 being equal to sin theta over 2 is equal to what? Equals to the square root of plus or minus the square root of 1 minus cos theta over 2, dividing this by square root of plus or minus the square root of 1 plus cos theta over 2. So if you simplify this one, what do you think we're going to get? We have tan theta over 2 being equal to the square root of 1 minus cos theta over 2 divided by 1 plus cos theta over 2. So we change the sign, we get the reciprocal. Shall have tan theta over 2 being equal to 1. So it will be 1 minus, we have 1 minus cos theta over 2 times 2 over 1 plus cos theta, like that. And then you have the square root. So we simplify. So here that this 2 and that 2 will go. So you're going to have tan theta over 2 being equal to the square root of 1 minus cos theta over 1 plus cos theta square root, like that. So those are the half angle formulas. Now, this one's being the half angle formulas for the both of them. So, any question? Now, the other set of formulas that you also need to know in trigonometry, we have the factor formulas. Now, when we speak about the factor formulas, then we're speaking about the single angle formulas. Like, let's just have here the factor formulas. Factors formulas. Now, in this, we need to find, the expressions of sin A plus sin B cos A plus cos B sin A plus sin B, not sin A plus sin B, sin A plus cos B, where A and B are acute angles. The A and B are acute angles. So how do we go about this? So what we do, let us check as expression for sin A plus sin B. So in this, let A be equal to x plus y and B be equal to x minus y. Okay. So if that will be the case, we now have, we have A is equals to x plus y, and we have B is equals to x minus y. Let's call this equation 1 and equation 2. So if we add equation 1 and 2, so adding equation 1 and 2, you're going to have what? A plus B is equals to 2x. So 2x will be equal to A plus B. And then divided by 2, both sides, you're going to have x is equals to what? A plus B over 2. Subtracting equation 1 and 2, you're going to have A minus B is equals to 2y. And this means that y will be equal to A minus B over 2. So if you substitute A for x plus y and B for x minus y, our expression now will become, we have sin, it will be now sin, our A is what? X plus y plus sin B, which is what? Our B is x minus y. Then this will be equal to what? If you expand this one, the compound angle formula from for sin, shall have sin x cos y plus sin y cos x. That one is for the first one, for this first set. Then the second set shall have plus plus sin x cos y minus sin y cos x, like that. So if you put the right terms together, you're going to have, so you have sin y and cos x, sin y and cos x. So these two will go. Then if you check these two, they're the same. So you're going to have sin x plus y plus sin x minus y, this being equal to 2 sin x sin y, sin x cos y. But we know what is our x. But our x plus y is equals to A, x minus y is equals to B. This implying that x is equals to A plus B over 2, and y is equals to A minus B over 2. So this implies that sin A plus sin B is equals to what? So x plus y is A, x minus y is B, is equals to 2 Sin x, x is what? A plus b over 2. Then cos y, y is what? A plus b over 2. Now, so I would want you from these, I want you to find expression for sin A minus B, sin B. So find an expression for sin A minus sin B. So let us find also expression now. Expression for cos A plus cos B. Cos A plus cos B. We're still going to use the same approach. And in this approach, let's have it say that let our A be equal to x plus y, and then our B be equal to x plus y. So the same approach, you have already proved and showed that our x is going to be A plus B over 2, and our y is going to be A minus B over 2. So from that point now, it means that we need to expand cos x plus y plus cos x minus y. And this you're going to get what? For the cos x plus y, it will be equal to cos x cos y minus sin x sin y plus cos x cos y plus sin x sin y. So this first set here, up to that point, is the expansion for that. And this set here is the expansion for cos x minus y. So if you put the terms together, we shall have what? What is going to finish sin x and y, sin x and y, sin x and y will go. So we're going to have cos x plus y plus cos x minus y is equals to, if you check cos xy, so it will be equal to 2 cos x cos y. But you know what is x, what is y, what is x plus y. But x plus y is equals to A, x minus y is equals to B, x is equals to A plus B over 2, and y is equals to A minus B over 2. So you go to substitute, you see that cos A plus cos B will be equal to what? 2 cos x. X is A plus B over 2. Then cos y is A minus B over 2. So this one is the factor angle formula for cos A and cos B. So I would want you in this exercise here, I want you to check, find the expression, expression for cos A minus cos B. So let us also now go and find the expression for the next one here. Let us check expression for sin A plus cos B. So we are still going to use the same approach where we have said we have already shown that if A is equals to x plus y and B is equals to x minus y, then x will be equal to A plus B over 2 and y will be equal to A minus B over 2. Now again we expand this one to say that sine our A is x plus y plus B, which is cos. Cos B is what? B is what? X minus y. This will be equal to what? If you expand these expressions, we shall have for the sine x plus y, it will be sine x cos y plus sine y cos x, then plus cos x cos y plus, so this one will be plus cos plus sine x sine y. So if you can put the right terms together, in this case, you're going to get what? Sine x plus y plus cos y, cos x plus cos x minus y should be equal to, so if you check that, sine x cos y, do you have any other? You don't have. You don't have any other. So you realize that it's going to remain like the same way it is. Sine y cos y, we have that like that. So going to still remain with what? Just sine x cos y plus sine y cos x plus cos x cos y plus sine x sine y. So in this, if you substitute, you shall just have sine A plus cos B will be equal to sine A plus B over 2 cos A minus B over 2 plus sine A minus B over 2 cos A plus B over 2 plus cos A plus B over 2 cos A minus B over 2 plus sine A plus B over 2 sine A minus B over 2. So that one does not change. That. So from this point here, we need to check solution to trigonometric function or equation of the form A sin theta plus B cos theta. And for us to show that, we need to write this expression as a compound angle formula. And so we can say that we need to show that we need to show that what really that we need to show that we need to write a sine theta plus b cos theta as r cos theta, else maybe r sin theta maybe plus alpha. So what we took what we want to see, what will be the expression for r and expression for theta. So let us have it down here. If at all a sin theta plus b cos theta is equals to r sin theta plus alpha, then then we need to expand the right hand side. So we're going to have a sin theta plus b cos theta being equal to r. So if you expand sin theta plus alpha, it will be equal to sin theta cos alpha plus sin alpha cos theta. And so this one here is going to have, you open up this bracket, r. I want to interchange sin theta and cos theta so that we have r cos alpha sin theta plus r sin alpha cos theta. So on the left hand side, we have a sin theta plus b cos theta. So the reason why I had to interchange sin theta and cos alpha is so that maybe I can have the unison of the function, or maybe the equation of sin theta and cos theta. Now, if this is the case, if maybe we can cross this one like that, and then also again we can cross this one like that. If these two equations are equal, then it means that the coefficients of cos theta, sin theta must also be equal. So this means that a must be equal to r cos alpha. And also, coefficient of cos theta must also be equal. That is, b is also equal to r sin alpha. So this means cos alpha is equals to what? I'll divide both sides by r. I'll get is equals to a over r. And also this one means that sin alpha is equals to b over r. Equals to b over r. Now, if that is the case, we know that cos alpha, if this one is the right angle triangle here, if you can have the right angle triangle here, and call this angle here alpha. And this alpha, by the way, it ranges from 0 to 90 degrees. You can see where it is. So sin alpha, cos alpha is equals to adjacent of hypotenuse. So this one adjacent is going to be a of hypotenuse, which is what? R. Sin alpha is going to be opposite over hypotenuse. So it will be equal to b over r. So this tells us that r squared is equals to a squared plus b squared, implying that r is equals to the square root of a squared plus b squared. Also, you also need to get expression for alpha. You can say that tan alpha is equals to opposite over adjacent. And so this one means that tan alpha is equals to B over A. So therefore, alpha is equals to what? Tan inverse of B over A. So immediately now you get R and alpha. It means it's now possible for us to write the expression A sin theta plus B cos theta into that. Now I want us we do an example. Let us take an example. So an example, let us have an example. 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 We've been told given that 8 cos theta plus 25 sin theta is equivalent to R cos theta minus alpha, where R is positive, that is R is greater than 0, and alpha is in between 0 and 90 degrees. Find the value of R, and alpha, and hence solve the equation. Let's solve the equation, and then solve the equation. And then solve the equation 8 cos theta plus 25 sin theta is equals to 2 for theta is between 0 and 360 degrees. So how do you go about this question? First, look at the first statement here, MB1. You've been told that the first statement, given that 8 cos theta plus 25 sin theta is equivalent to R cos theta. And they want us now to find, first of all, the value of R and the value of alpha. So let us have the solution down here. So basically here we have to expand. We're being told that 8 cos theta plus 25 sin theta is equals to R cos theta minus alpha. When being told that these two sides are equivalent, this simply means that the two sides are equal. They are the same. When you talk of something are equivalent, then it means that they are the same. So our first thing is to expand R cos theta minus alpha. So we're going to have 8 cos theta plus 25 sin theta is equals to R. So when we expand cos theta minus alpha, we're going to get cos theta cos alpha plus, remember we said if here it is plus, this will be minus, if this one is minus, this will be plus sin theta sin alpha. So that now you have 8 cos theta plus 25 sin theta is equals to, open up the bracket with R, you have R cos theta cos alpha plus R sin theta sin alpha. But then if you look at the right hand side, our equations are in terms of cos theta and sin theta. So we want to make sure that sin theta, cos theta and this sin theta, they are at the far end. So we're going to have 8 cos theta plus 25 sin theta is equals to r cos alpha cos theta plus r sin alpha sin theta. So that if you can check this part here, if these two sides are equal, then these coefficients of sine theta and coefficient of cos theta must be equal to this one and that one. Like in this case now, we know that 8 will be equal to the coefficient of cos theta on the other side, which is equals to r cos alpha. And also again, this one here, 25, will be equal to 25 will be equal to r sine alpha. We have said that if this one is the case, then cos alpha will be equal to 8 over r, and sin alpha will be equal to 25 over r. And if you happen to draw the right angle triangle, you said this one here being our alpha, then we know that cos alpha is equals to adjacent of hypotenuse. So our adjacent will be equal to 8. So this was adjacent over hypotenuse. And then sin alpha is equals to opposite over hypotenuse. So it means that the opposite is 25. And the hypotenuse will be equal now to r, because it is 8 adjacent of hypotenuse, which is r, opposite of hypotenuse, which is r. So to get the value of r, it is quite simple, because you can be able to see that r squared is equals to 8 squared plus 25 squared. And so you get that r is equals to the square root of 64 plus 625. And we get what? 625 plus 64. You'll get r is equals to the square root of 689, which square root is, which the square root is, r is equals to 26.25. Now we already have r. So what about the alpha? We say that alpha is equals to tan inverse of opposite, which is 25, over adjacent, which is 8. So tan inverse of 25 over 8 is equals to alpha is equals to 72.26 degrees. So we already have now the values of alpha. We have the values of alpha and r. And so it means it's now possible for us to solve. So this means that hence now equation can be equal to, equation is equals to 8 cos theta plus 25 sin theta is equals to our r is what? 26.25. Then cos theta minus alpha is 72.26. Like that. So we are being told to solve 8 cos theta plus 25 sin theta is equals to 2. Now I want you to note here, if this part is equals to this part, and you know this part here is equals to 2, that means also this part here is equals to 2, right? So if we agree on that, then it means we're going to have a problem being equal to 26.25, which is our r, cos theta minus 72.26. being equal to 2. Why? The left-hand side here is equals to 2. This one here is equals to 2. And so therefore, the right-hand side will also be equal to 2. So from that point now, we can say we divide both sides by this 26.25 divided by 26.25. So this means that we have cos theta minus 72.26 is equals to 2 over 26.25. Now, maybe I want you to remember something here. I just want you to remember something. If at all, maybe we know that cos 60 is equals to 0.5. So it means also 60 is equals to cos inverse of 0.5. So if you press your cos inverse of 0.5, you'll get 60. Also, another thing that I want to remind you, it is that how we use the unit circle to obtain the other values if it is for sine or cos. So if you can have a unit circle like this, and then our unit circle should have the axis inside, so that it is 1, 1, negative 1, 1, like that. Now, for the sine, we check the y-axis. And then for the cos, we check the what? The x-axis. So this one's the x-axis, not the y-axis. Why? You'll find that cos 60 is somewhere here, and we get 0.5. But also again, if you check cos 300, so cos 60 is equals to cos 300 because it is 60 minus 60, which will be equal to 0.5 because you are reading the positive x-axis, right? So in this case, if you can continue with this one, you're going to say that theta minus 72.26 is equals to cos inverse of 2 over 26.25. So you'll get 0.72.26 is equals to, so what is the cos inverse? Cos inverse, how do you get the cos inverse? You press shift and cos. Shift and cos, you get cos inverse. So cos inverse of 2 over 26.25. So we get this one here, it is 85.60. Minus 20 theta. 85.60. Now, if I draw the unit circle here, like that, and you have said that for the cos, we check the x-axis. So if this one here will be my 85 degrees, 85.63 degrees, that means the other value will be 360 minus that angle. So which will be equal to what? So we take 360 minus 85.63. So it will be also be equal to 274. So this one is 85.63. So meaning that theta minus 72.26 is also equal to 274.37. So in this case now theta is equal to what? Theta will be equal to 274 plus 72.26. So that will be equal to 346.63. And also if theta is minus 72.26 is equals to 85.63, then this means that theta is equals to what? So 85.63 plus 72.26 you'll get it's 157.89. So then you can see now our theta is equals to, we have that 157.89, and also theta is equals to 346.63. That is how you solve that kind of an equation. And I hope maybe if you get another question of the similar, so we shall check. I shall look for questions on this, then I send you. Otherwise, the next topic that you're going to start is hyperbolic function. I'm going to send also a video on hyperbolic function today. You check and write the notes, and we meet in the next class. Thank you so much for your cooperation. I wish you a good day, and let us meet in the next class. Thank you. Bye.